All right, hello everyone. Welcome back to the another class of computer networks and artificial intelligence. So today is the last class about email security. So for your recap, at the first class of email security, we covered the sender-oriented, security email security protocol such as SPF and DKIM and DMARC. So these protocols are mainly to check whether the sender is, um, I'm sorry, authorized to send the email on behalf of this domain name, and also the key was to provide that the email content has not been forged using a public key encryption, and DMARC is about the policy for the receivers to determine what if the check, either checking of SPF or DKIM are failed. Okay. So at the second class, we talked about the DANE. I introduced the DANE concept, why DANE was originally introduced, and how DANE is can be deployed, and the current status of DANE deployment. Okay. But if you guys remember correctly, then you might want to recall MTA-STS protocol. So for your recap, I'm going to show you one slide that I showed you at the first class at the email security protocols. So I hope you guys remember there are two perspectives of email security protocols that I'm going to teach you, that I've been teaching you throughout the 3 lectures. The first perspective is sender versus receiver. Okay, so when the email comes, you may want to check if the sender is authentic, the content has not been forged using SPF, DKIM, DMARC, and the BME. From the receiver's perspective, you may want to check if this receiver, mail recipient you connected, was authorized the entity, right? If that domain name is correct, that the mail server is the one you are thinking. And if you want to encrypt the email communication that the certificate comes, then you want to check if the certificate is actually authentic. So I talk about MTA-STS protocols and DANE protocols, but when I talk about MTA-STS protocol, I briefly mentioned that we're gonna recap this protocol again after showing you how DANE works. So I guess it is a good time to talk about MTA-STS. But for your brief recap, let me briefly talk recap again how a DANE protocol works, right? So DANE. So at the high level, DANE uses TLS plus DNSSEC, all right? So for the senders, receivers, the TLS server perspective, SMTP servers, and it has to first publish a TLSA record on their domain name, right? The domain name authoritative servers. And this TLSA record basically contains the information about the public key of the certificate. Sometimes it can have the entire certificate information, such as base64 encoded certificate. But as you can imagine, it is too big, too large. So typically, the TLSA record is just a hash of public key in the certificate, okay, which is very similar to DS record, right? So from the client perspective, it has to first fetch a TLSA record, DNS records, and of course, it is signed by DNS key. So DNS resolver has to validate all the signatures, on the chain of trust up to the root zone, right? So, yep, like this, and also using a signature. And after that, if the validation done, the TLS client will receive the TLSA record from its DNS resolver. Now, TLS client has one piece of information, which is the public key information of the certificate, which will be coming from the actual TLS server. All right. So the server will give a certificate, right? And also, if you think about it as a SMTP server, the TLS server will give you a command to the client that, hey, I support start TLS. If the start TLS command doesn't come, the TLS client may think that, oh, the start TLS command must have it dropped by some middle attackers, because this TLS server already explicitly showed that they are this server supports start TLS by uploading a TLS record. So the existence of TLS record indicates that I support start TLS. All right. So TLS client find a certificate, and also it tries to find, it tries to match between the TLS record's public key and the certificate information. If it is matched, then it's done. Certificate validation process is done, so that the TLS client can use its certificate and use the Diffie-Hellman key exchange or whatever else to make the asymmetric keys and secure to initiate the secure communication. Right. So now let me go back to MTA-STS protocol. Okay. So MTA-STS protocol is very similar to the DANE, but it is less secure. All right. So let me tell you how it works. As you can imagine, one of the challenges of DANE is that it relies on DNSSEC, right? And of course, we learned from a previous class, DNSSEC deployment rate is really, really low. Of course, in some ccTLDs like SE.NL, their deployment rate is over 50%, but at .com, .net, .org, they are less than 1%, right? So MTA-STS tries to achieve a similar goal, but it leverages TLS other than DNSSEC, right? So let me tell you how it works. First, the sender SMTP server has to look up this domain name. So if it wants to send an email to google.com, before looking up the SMTP server, it has to first try to fetch this record, MTA-STS underscore MTA-STS.google.com, right? So if this google.com server supports MTA-STS, then it has to publish, excuse me, a TXT records under this query name, okay? So it is very similar to TLSA record, but instead, it just uploads this MTA-STS version and the identifier number without having any public key information, just under this specific queue name, okay? Then, after the client finds that there is a MTA-STS record on the target server, it next fetches a policy file through HTTPS. That is the differences, okay? So for the DANE, it tries to fetch public key information over DNS, right? But instead, MTA-STS, after finding out the existence of the MTA-STS record, MTA-STS queue name of TXT records, it immediately tries to fetch a policy file through HTTPS, okay? So this is the actual policy file served by google.com MTA-STS. So this is the file convention. So if it tries to send the email to yahoo.com, the only strings that the sender SMTP server replace is this part, white part, okay? Then let me just Then this is the actual policy file text information because it's a text file. It says, hey, this is the version number and mode is enforced. I'm going to recover it later. And this is the list of allowed MX servers. And this is the caching period of this policy file. So there are 3 policies, enforced, testing, and none. For example, enforced, if the start TLS command does not come, then the sender has to reject the communication. If it is testing, it is up, I believe it is up to a sender's policy. But you may want to double check. If it is none, then even if the certificate doesn't come, you can the sender just initiated TLS connect, the plain communication, right? So as you can tell, if you look up the google.com MX records, you can find that it is matched with the MX records in this policy file, all right? So after finding out this policy file, the sender can initiate the TLS connection, right? So you might be wondering, what if this MTASTS google.com record, it is not actually a record, it's TXT record, would be dropped by an attacker, right? So imagine that the sender tries to fetch a MTASTS TXT record from the receiver, and let's say the attacker just dropped the TXT records to force the client, SMTP client, to communicate with the receivers using this plain SMTP connection. It is totally possible, right? Because it does not mandate DNSSEC. Any attacks can be happening on the DNS level is still possible, right? So it is still vulnerable to DNS attacks. So that's the reason why DANE is more, and it's considered to be much more secure than MTASTS. So if the receiver side SMTP server supports both protocol, then the recommendation is to use DANE. Okay. So now let's move on to the next topic, which is DANE management. Okay. So the reason why I'm allocating 2 hours for DANE is it is really promising protocol, but it is a relatively hard to use. So DANE has been the usage has been increasing. For example, Microsoft started to support DANE. This MTASTS and the DANE is like two competing protocols. For example, Google supports MTASTS, but they do not support TLS. I'm sorry, they do not support DANE, but in case of Outlook, they support DANE. Okay, but anyway, DANE is more. I think DANE is much more secure. So DANE is the kind of future to go. But the thing is, from our research, DANE is really, turns out to be really hard to be managed correctly. So let me tell you why. So from our last class, we found that the DANE deployment is really rare, but of course the good news is increasing. So in case of .nl Netherlands and .sc Sweden shows high deployment rate because of some financial incentive. For example, I guess the contractors to work with the German industry, I believe they have a set of qualification to be set of criteria to qualify by the government. I believe one of the criteria for a mail server is to support the DANE. Yeah. So anyway, so there are really good initiative to support this DANE protocols deployment, right? And also from the last class, we find that there are some, many misconfigurations, and most of the prominent example of the misconfiguration is sometimes they do not have a DS record. So which means they try to support DNSSEC, but they are kind of partially supported. So they have DNS key, but so that you can verify the outer SIG record signature. But if you want to verify the authenticity of the DNS key, you fail because there is no chain of trust. Missing DS record, right? And sometimes we find that 4% of the certificates, they do not match with their TLS records. This is really strange, right? Because they try to support DANE for some reason, even if they do have a TLS records and a certificate over TLS, this two does not match to each other, which it looks really strange, right? So the motivation of this class topic is why, right? So we are trying to understand why they fail to support DANE correctly, okay? So let's talk about it. So there are many entities involved to support DANE correctly. The first one is DNS server, right? You have to manage your authoritative server correctly. And the other one is SMTP servers. So each server can be self-hosted or outsourced, right? So what I meant by self-hosted is you can just purchase a EC2 machine, right? And you can manage all the DNS servers and the SMTP server by yourself, right? Or if you don't want to deal with all the troubles, by yourself, what you could do is you can just use, Outlook.com services or Cloudflare DNS services, basically outsourcing, your mail capabilities to other third-party companies. Right? So self-hosted means domain administrators, you are the domain name holder, right, owner. Domain name owner manages both DNS servers and SMTP servers coherently. So you have to focus on this terminology coherently, because if you uploaded the wrong TLSI records, does not match with the certificate provided by SMTP server, then you're screwed, right? Because the certificate does not match with the TLSI record, then basically the validation is failed, right? So, and outsourcing. Domain name administrators can also outsource DNS servers as well as SMTP servers. So before moving further, you have to understand this slightly different nuance of these two terminologies. Okay. Yeah. Then we might be wondering, all right, there might be some differences in the quality of management depending on who manages each server, right? You might be easily think that if the server is outsourced, then you pay someone to manage your servers much efficiently. So you might be thinking that the quality of data management quality is much better if you outsource some services to third-party hosting providers, which is kind of true. But we're gonna answer the questions later. So actually, there are three cases of data management, right? The first one is outsource. So domain name owners can simply outsource SMTP server. In that case, you have to notice that you cannot simply source SMTP server without sourcing DNS server. So which means if you'd like to outsource SMTP servers, you have to use SMTP server's DNS server as well, right? So SMTP server outsourcing, we simply call it SOKs, right? But sometimes you decided to use a DNS, you may want to outsource DNS server only, right? For example, you decided to manage your self-hosted SMTP server by yourself, but you want to use some third-party CDN's DNS server. So in that case, SMTP server self-hosting and DNS server outsourcing. So we call it SSDOK, right? Then you might be wondering, hey, why isn't it possible to outsource SMTP server only, right? Because if you'd like to send the email, you have to look up the MX records, and the MX records of that SMTP server is typically bound to the SMTP server itself. So that MX record can be updated and modified in the DNS servers of the SMTP servers. They usually come together, right? Another one is, the other case is just self-hosted, right? Domain name owner decided to manage SMTP server and DNS server simultaneously, all right? So what I'm going to show you later is we're gonna focus on the kind of misconfiguration ratio depending on each cases. So we applied a similar techniques that we use for the other paper presentation as well. So we collect the data. So we scan all the TLSI records and other relevant DNS records on a daily basis. And at the same time, we collect a certificate by connecting to the SMTP servers, right? So then the first question is, we split the system into three different categories: self-managed, outsourced SMTP server (SO), and SSDs, and self-managed DNS server and self-managed self-managed SMTP server. So we have three cases. The next question is how you're going to classify all different SMTP servers into this bucket, right? 3 different buckets. To do that, we first calculate the popularity group, the SMTP solvers based on the IP address. The high-level intuition is if many SMTP solvers are managed by a single IP address, it is typically means it is managed by a big authority, right? So we found that 1.7% of domains are outsourced, and using the same, we also use the second level grouping. So for example, sometimes second level domain name have a multiple domain name under the second level domain name, which is the sub level domain names. They share the same second level domain, which means it is also typically managed by same domain. And also we calculate the popularity of the SMTP servers, and also that we can find the first one. Yeah. So for your recall, SO means SMTP outsourcing, and SSDO is self-hosted SMTP server, but the DNS server is outsourced, and SSDS is both are self-hosted. So as you can quickly tell from the figure, the x-axis is a date, and y-axis is a percentage of incorrectly configured domain names. You might be, you can immediately notice that if the SMTP solver is outsourced, then it is really, really hard to be misconfigured. Of course, it is so naturally true because these big hosting providers have much more manpower to manage each domain incorrectly, and also basically that's what they paid for, right? So the ratios of domain names that support DANE incorrectly in SSDO and SSDS cases are much higher than SO, okay? So one quick takeaway is if you'd like to manage DANE by yourself, then the numbers show you that it will be not that easy, okay? So because the focus of this work is to find out why it is so hard, so let's focus on the other two cases that either DNS or both SMTP DNS servers are managed by the actual owner. So there are two main failure reasons since we already covered in the DNS the previous class. The first one is DNS failure, or the other one is mismatch. Okay. So the y-axis shows the invalid TLS records due to the DNS failure. And of course, as we already learned, 99% of DNS failure are due to missing DS record. Okay, so if you pick the wrong registers, then you're not able to support them correctly. And if you're focusing on a mismatch, it is really surprising that still less than 30% or less than 20%, from 16 to 20, 30%, 23% of the SMTP servers have a certificate which is not matched with the TLS records, which seems really bizarre, all right? Because DNS configuration error, it has nothing to do with their capabilities, right? If their registers, we already learned from DNS class, right? If their registrars do not support DS record, then there is no way you can support DNSSEC, right? But in case of mismatch, right, you can control, right, this mismatch, right? Because you deploy DANE, all you need to do is to make it coherent, your certificate coherent with the actual TLS records coming from the DNS server. So, which means 20% of them, for some reason, they're still having a record, DNS record, that does not match with the certificate, which is really bizarre, right? So let's focus on this perspective. So why mismatch happens? So we check the percentage of TLS records are mismatched with the certificate at the time of the scan, but can be mismatched with the certificate used before. So the reason is in other words, if the 1 hour hypothesis is, as time goes by, if you roll over, if you change the certificate, and if you for some reason forgot to update your TLS records, then we'll find that the more and more mismatched certificates can be found as we increase our time span, right? So for example, the x-axis is the date, right? And as we increase our monitored time window and we compare if this certificate is matched with the TLSA records or not, as time goes by, we see more mismatched certificate, which means they forgot to update their TLSA records, right? So certificates are changed as we scan, over time, but the corresponding TLSA records are not updated timely, right? So, which is incorrect key rollover, okay? So, to update, again, it is similar to DNS class. DNS key is similar to your password, which you have to load, you have to update frequently. So similar to a certificate, you have to, update your certificate over time. So it requires synchronous management between SMTP servers and DNS servers. So if you decided to change your certificate in your SMTP server, and as soon as you update the TLSA certificate, you also need to make the TLSA records updated, right? So there are key rollover process, right? So which means before actually serving the certificate, new certificate, before serving it, you have to publish a new TLSA records along with the old one first, right? Because DNS record can be cached, right? Which means even if you change your TLSA records and the certificate simultaneously, right? Then the client will fetch the new certificate immediately, right? But but the TLSA records the client has fetched might be from the cache, which means the TLSA records could be still stale, not a new one, right? Which causes a mismatch, right? So to prevent the situation, the solver has to publish the new TLSA records in advance along with the old one, right? Because the client will fetch two TLSA records and they try to compare each one with the certificate. If either one matches, then it's good, right? So it doesn't need to match both of the TLSA records, all right? So SMTP server must publish the new TLSA record to a DNS server in advance, at least 2 TTL before time to live, which is the caching period of the DNS records. Incorrect one might be the early retirement, as I just described earlier, or late introduction. So they may upload a new TLSA records very late. So if it is too early, if it is too late, then it causes a kind of mismatch, right? So we calculate the miss percentage of the percentage of incorrectly configured rollover, and it is stunning, right? Most SMTP servers in all management cases conduct rollover incorrectly because they late introduction of a new TLS records. Okay, so and one major finding what we observe is also a certificate needs not be issued by CA because that is a whole focus of DANE, right? Because the DANE was originally introduced to cut the tie, right? To untie with the CAs. But what we found was still many certificates is actually signed by CAs, right? So more than 99% of TLSA records use those usages, which means they are still using a certificate issued by the CA. And also, if you're using DANE TA, DANE, there are multiple usages, and actually you don't need to roll over, right? But many SMTP servers we found conduct key rollovers. Why? This is because they're using a popular CH, which is called Let's Encrypt. So Let's Encrypt is in the Sectigo a free automated CAs, so that you can configure your web server and get the certificate issued by the CAs very easily in an automated fashion. But the thing is, please remember that in my TLS session class, this certificate's lifetime is usually 90 days, which means if you get the certificate using a kind of module like a certbot, using a less encrypted module, then you don't need to do anything. It will, in fact, you will get the new certificate every 3 months because the lifetime is just 90 days, which means you will renew the certificate every 90 days. And this certificate will change with the new public key, which means you have to make your DNS solver updated, right, with the new TLS server. So which means there is an automated CA software to get the certificate every 90 days. But at the same time, you have to have another processes that fetch this key information in advance and upload it to the DNS TLS records. And as far as I know, this kind of tool does not exist yet. Okay, so that is the problem. So what we found was this DANE uses allows a TLS records, but incorrect rollover ratio is increasing and it's exploded since October 2020. This is because Let's Encrypt now they introduce a new root store. So what they decided was, hey, we are retiring a old root certificate. So we are signing at this moment. The new old certificate will be signed by a new intermediate. So they retire the old one. But the owner, the certificate, the owners, they forgot to upload this new CA's, intermediate keys, so which causes all the failure, right? So that is the reason why this certificate misconfiguration ratio is, kept increasing. So far, we answered some questions using data, right? But in the end, that is the kind of this is the kind of challenge of kind of data-driven study. Sometimes we don't know what is the underlying reasons for a certain behavior, certain phenomenon, right? So when you see this kind of, when you face this challenge, we usually contact them, right? So to better understand the rationale. So we did a survey to a popular email providers to understand why this is happening. So we categorized the surveys into 3 different sections, and we surveyed 39 email operators, and we focused on 24 email operators that support DANE, and we found that 22 operators use a CA issued certificate, and for compatibility with the other SMTP servers, they do the reason why they still use CA issued certificate is to provide a backward compatibility with the other SMTP servers that do not support DANE yet. All right. Another finding was we found the 6 operators contact rollover correctly with the self-developed automation script, right? Because currently there is no good system that automatically roll over with the new certificate by uploading a new TLS records in advance. So they decided to make their own automation script to do so, to roll over it, okay? Which is kind of sad, which means if you do not have such manpower, then, you're screwed, right? So it is really hard to maintain the rollover process, really in a good way, right? So quick conclusion. So we investigated why domains fail to manage DANE correctly. And there are 2 reasons, and the missing DS record and the key changes due to automatic certificate reissues of CAs. So we discovered that 90% of SMTP servers perform the key rollovers. They did it incorrectly, okay? So yeah, this is a kind of, a sad conclusion. But once we believe, so one paper, one piece of research that I didn't cover at the TLS class was back in the early 2000s, the HTTPS adoption ratio was really small, okay? But also at the time, there are lots of HTTPS servers that are misconfigured. because it was really hard to configure it correctly, and you had to do it all manually, right? But as time goes by, it is majorly driven by Let's Encrypt. There were new software that automate this process, automatically without any, minimizing the human efforts. After that, the HTTP ratio just spiked. Now these days, over 90% of the web traffic, measured from Firefox, the traffics are over HTTPS, right? Thanks to this kind of automated script. So what I guess is, still email system is really insecure. It can be really easy to be spoofed, right? So I believe the DANE is the a future, but still there are no strong initiative to support such kind of rollovers automatically. So if this software is developed and widely disseminated, then I believe the percentage deployment rate will be surged. Okay? And also the misconfigured ratio will be also dropping, right? So to wrap it up, this is the last class of the email security. So next class, we're gonna talk about the routing security. But to wrap it up, there are two perspectives we covered. The first one is sender's perspective, whether the sender is authentic, whether the sent email has not been forged, or it is spam or not. And the other one is receiver perspective. Am I communicating with the right entity? Am I sending an email to the right entity? And if this communication channel is secure, encrypted, and these two protocols are to support this functionality, I introduced MTA-STS and DANE. And DANE mandates DNSSEC, which is the kind of weakest deployment link, I believe. And MTA-STS does not mandate DNSSEC, rather it uses HTTPS as a TLS to get the policy file. But of course, it is prone to kind of man-in-the-middle attack by dropping the MTA-STS record. All right. So I hope you guys can depict a kind of big picture of this email security protocols. And yeah, I hope you enjoyed the class. And again, if you have any questions about the email security protocols, please feel free to send out an email. All right. Thank you so much. And I hope to see you in next class. All right. Bye.